Hello, welcome back to Section 2 of Chapter 1 in the Regents Biology course. We're looking at how scientists work in this section. Now, scientists are going to design an experiment. They're going to first state the problem, second, form a hypothesis, third, set up a controlled experiment, fourth, record and analyze results, and finally, they're going to draw a conclusion. Now, this process is going to be very important to you because there are going to be questions about it on your Regents exam. Now, when we look at experimentation, we have a controlled experiment, is where you control all the variables in the experiment. This is going to be something that you're going to perform in a lab. A lab experiment is going to be you're going to want to run it on a controlled situation. All right? Now, a variable is anything that can change. So anything that we can alter in the experiment is going to be a variable. Manipulated or independent variable is the variable that is deliberately changed. These are going to be terms that you're going to need to know. Independent variable, the variable that is changed, is very, very important when it comes to your experimental design for the Regents. The responding or dependent variable is the variable that changes based on the manipulated variable, hence the term dependent. It is dependent upon the independent variable. So knowing the difference between these two terms is extremely important because you will be asked to identify them on the Regents exam. And when testing a hypothesis, it's important to change only one variable at a time. If you change more than one variable, you could end up having multiple items cause the response. All right? So if you're doing if you're going to a game, you have a game after school, and maybe you change what you have for lunch, and you get new shoes for the game, new cleats. That is two variables you change, and so you have the best game of your life. That could be two things that caused it. Maybe it was the new cleats made a big difference. You could get better grip on the field, or maybe it was the fact that your nutrition was better. You can't be certain because you changed two variables. And it's important to test and retest any findings. All right? So if you continue along that path, you can test and retest and see what caused them. Now, there are several experiments here that show experimental design that we're going to go over, that you just need to be familiar with. And this experiment was a test on spontaneous generation. And basically, Reddy went through a series of tests to see what caused the flies to form. They thought the flies just appeared, or the maggots just appeared. And so what he did was he had identical sets of jars. He kept everything the same. The one variable he changed, though, the independent variable, all right, is the covering on those jars on the left, or on the right, I'm sorry. The covering on the jars on the right, that's the independent variable. The dependent variable is the formation of the maggots on the meat. All right? So the dependent variable depends on whether or not they were exposed to the flies. Spallanzani's test was to see if microorganisms grew in a gravy. He boiled them. He sealed one of them. All right? So that's the variable that is changed, the independent variable, the sealing of the flask. And as we see, the sealed flask did not grow microorganisms. As they were boiled, they were deemed microorganism free, and the exposure to the air allowed the microorganisms to colonize. Now, Pasteur's test, they thought that maybe oxygen was needed for microorganisms to form, so he put this little N-shaped neck onto his tube, which allowed oxygen in. That would be the independent variable. The dependent variable is whether or not the microorganisms grew, and then he tested that and removed the neck, and we found that there was microorganisms. So when experiments are not possible, so sometimes you cannot have a controlled experiment. Obviously, a field test. All right? Field tests, scientists will take all the precautions they can to prevent interferences. Obviously, when you're studying an animal in the wild, you can't control everything, but you do your best. You use field cameras or hide the recording device or whatever you're doing. Experimentation, when a theory is when a hypothesis becomes very well supported. All right, we have a lot of support. All right, that becomes a theory. So a theory applies to a very well-tested explanation of how something occurs. So the theory of evolution explains how life evolved on Earth. All right? People constantly think that a theory is less than a law. There's no law of evolution. You can't have an explanation that happens the same every time because evolution occurred differently. Gravity is a law, but the law of gravity does not explain why it's happening. So when testing a hypothesis where you can't perform a controlled experiment, it's important to still follow as many of the rules as possible. All right, so you're going to want to still cover those. Some famous biologists, Andreas Fernandez, published a book called On the Structure of Human Body, which provided the first detailed, accurate study of human anatomy. William Harvey, first person to be able to describe the circulation of the blood. He shows how blood pumped through blood vessels and returns to the heart. Anton von Leeuwenhoek perfected a simple microscope, able to observe microorganisms. He discovered the protozoa. He's the first microbiologist. Charles Darwin, we'll spend plenty of time on him. Born the exact same day as Abraham Lincoln, published a book on the origin of the species, and states that all life has evolved into its current form over millions of years. Louis Pasteur developed the first vaccine against anthrax. Watson and Crick determined the structure of DNA. So, in the grand scheme of things, you're going to need to know Darwin and Watson and Crick. Those are the two that we're going to go over pretty intensely throughout the course.